Okay. Good morning, class. This is Mr. Bean. How are you guys doing? We're now going to move on to assignment or lesson 13.3, introduction to what's called the Bohr atom. Now, on my screen here, you should see this assignment here. And some questions we want to answer before we start is, how do stars work? Because we are in astrophysics. You're probably wondering why we're studying all the atoms and stuff like that. And very valid question. And so a question you might have, is how do stars work? And more importantly, how does the sun shine? Well, in order to answer that question, we have to understand how atoms work. Okay, and so before we get that, let's take a look at this model here. This is called here's the sun, of course, and here's the core. We have a lot of nuclear reactions occurring. And this is where photons are created in the core of the atom, in the core of the sun. A lot of very hot temperature, lots of pressure occurring right here. So let's take a look at this and kind of see what happens here. Okay, this is what's called the random walk. Okay, so there's fusion going on here. Let me go ahead and let's do one more simulation here. Let's try it again. And there we go. Let's try a couple more just to make sure. Okay. And there we go. All right. So you see this. This is called the random walk. And let me go ahead and do some notation here. Let's go to draw here. Okay. So in here, this is known as a random walk. So the electron started, well, this is the core of the sun. This is where fusion takes place. And what happens is that a photon is released. It collides with other hydrogen, helium, other gases inside the sun. And this whole process here takes about 100,000 years, roughly. So 100,000 years for when the photon is created to finally make it to the surface of the sun. Now, once it's here, right, surface of the sun here, here's the Earth. Let's say, right, here's the Earth. We'll put an E here for the Earth. Here's the Earth here. And once it's here, it takes about, what, roughly 8 minutes or so to reach the Earth. I'm going to make this a big E here for Earth so we can see it better. Okay, there's the Earth here. And so this whole so when you go outside and feel the sun touch your face, just know it's about 100,000 years and 8 minutes, plus 8 minutes to reach you. Okay, so but how does this process occur is we have to talk about atoms and how atoms work. So let me go ahead and minimize this here. Let's go ahead and change it back to mouse. We'll minimize this here. Make this a little bit bigger here so you can see it. And let me do some erasing here real quick. Let's erase that. See, erase, erase. Okay, all right, back to mouse, and let's close this down. So here's the sun shining here, and let me do an eraser again. Let's erase that. And so, and some more erasing here. Okay, back to the mouse again. Okay, so we have to understand how atoms work. Well, there are some different kinds of models of the atom. Here is according to Dalton. The atom was kind of like a billiard ball when playing pool. The next model was kind of a guy named Thomson. It's called the plum pudding model. That's a big circle with positive charges and negative charges all mixed in here like a pudding. Then a guy named Rutherford came up with this model here, which you might be kind of familiar with the atom. And then finally, a guy named Niels Bohr came around, early 1920s, with the introduction of quantum theory. This was called the Bohr atom. Okay, and we'll be looking at this. But now the current model is the quantum mechanical model, which we'll talk about a little bit, quantum mechanics. But this is the Bohr model. Each new model contributed to the model that we use today. Even the current model, the quantum mechanic model, doesn't give us an exact idea of how electrons interact. All right, so as you do this assignment here, 13.3 here,